See, this works? Perfect. Okay. I think we're all set. Let's just check. All right. Cool. So my name is Vlad, and in this session, it's going to be an English session, so you still have time to get one of those devices to hopefully follow me, because might speed up this talk. We'll see. Let me start my timer too, actually. Great. All right, so in this session, we're going to talk about 3D graphics and the web platform. Some of the sort of sections in this talk, we're going to talk about WebGL, Web VR, AR, and a bit about WebAssembly and how that fits in into how that can help us with 3D graphics in the browser. A bit about me, you can find me at Vladikov on Twitter and GitHub. I'm from Toronto, Canada. I work at Mozilla. This was supposed to be an official photo, but this is like this is not my desk. This is not every day. But I work on Firefox. In particular, I work on cloud services. But I'm also very passionate about 3D graphics and basically 3D graphics in the browser. Right when WebGL first came out, I started building things, tried to participate in as many hackathons as possible that related to 3D graphics. So I built like several games and experiences. This was like in Chrome 27 days. I built this GitHub archive room, which would allow you to, let's see if this loads up. Well, let's see. You could fly around and explore your GitHub archive, and if you send a pull request or somebody commented on your pull request, you could see all that information. So going back here, I guess in this talk I wanted to, it has several goals to first of all inspire you to build things hopefully with 3D WebGL APIs and things like that, but also kind of recap the history of how we got where we are right now with like WebGL and kind of related APIs, and also to kind of look at the current state of tools and also the future where we're going in the next year or maybe the next couple of years. So if we look at this this slide here, we can see that WebGL kind of began. The WebGL working group started working on the spec in 2009, and even before WebGL was complete in kind of 1.0 was complete, we already had 3JS in 2010, sort of usable in the browser, which was very exciting. 3JS provided a very simple API. You didn't have to learn WebGL from scratch. You had to know JavaScript, and you could just use that to build make a spinning cube and go from there. Once we had WebGL 1.0, in 2012, Sketchfab.com came out, which is like YouTube for 3D models. And if you haven't been on that site, it's very exciting to also like get inspired of what's possible to run in a web browser. 2013, we got ShaderToy.com. That's kind of a low-level demo space for WebGL. And we start getting new frameworks and libraries, Pixie.js, Play Canvas Engine, things like that. So kind of going beyond having more libraries than just 3JS. And I guess the WebGL working group and those people related to that started, they were done with 1.0, so they needed something else to do. So they started working on the WebVR spec. So the WebVR working group started that in 2014. And a couple of years later, WebVR 1.0 spec has been finished. If there's anything that happened in kind of WebGL related things in the browser in 2015, please let me know. That's like a lonely year. Nothing happened, but it was a bad year for that. So this year we got WebGL 2.0 in Firefox earlier, like February and so on. WebAR working group started working on AR because VR was completed, and other cool projects like React VR got started. So if we look at the future, this is kind of my opinion of what's going to happen. Following the existing timeline, we can see that WebAR 1.0 will probably be done soon enough, which is exciting. We have 3JS and other libraries will hopefully support WebGL 2.0. Cross-browser WebVR, which means all devices and all the browser engines would work, will just simply work no matter what device you have. Better tooling for 3D, because we already have all these new APIs and we want to build these cool experiences. I'm really hoping that we'll get better and better tools. And also, I guess finally, like VR and AR web browsers. What that's going to look like, I'm not sure. There's some early prototypes, but it's also very, very exciting space. If you're just sort of getting started with this, just want to like run a cube or a sphere in a web browser, these kind of the 4 contenders you can take a look at. 3JS, one of my favorite libraries. I love it. It's just a great API. It's been around I think for like 7 years now. It's amazing. BabylonJS, which started like which was like a collaboration Microsoft project, is also very kind of alternative to 3JS. There's also the Play Canvas WebGL game engine. You can find it on GitHub, and also the PixieJS 2D JavaScript renderer, which relies on WebGL to render scenes. And that also has like many projects from like indie basic experiments to like official. I think Disney uses that for some of their work. So, just wanted to give a quick kind of three demos here. First of all, here's the site I like, which kind of embeds this WebGL scene right into like alongside a basic HTML page. In this case, you can like modify your Xbox controller and make it really ugly if you want. But this is what I like to see more of this, where the 3D experience does not take over the whole page, but you just if you have a capable computer or a capable device, you can make this spin. If you don't have a good graphics card, you just get this. But I feel like sometimes developers forget that you don't have to take over the whole full screen to build a 3D experience. Now, yeah, so this is something I like and I'd like to see more of, and hopefully we can kind of push the web forward with these sorts of experiences. Cool. So another example of something that we, as a community, got was some of the new projects that are built on top of existing frameworks. So, for instance, let me see if this loads up. Trying to connect. Here we go. Nope. All right, let's try. Ooh, it's an old network. There we go. Let's try this. Yep. I'm going to get on Wi-Fi really quick. Okay. Sorry, Mike, I'm going to use your credentials. There we go. Perfect. Okay. Right, so there we go. So now we have these new tools that are built, like a lot of them are built on top of 3JS, which give you like a physics engine, a nice kind of good development environment. This is an example of WHS.js, Whitestorm.js, and this is kind of the things what I'd love to see. Well, I would, if I had this when I first got started with WebGL, it'd be so great. Like physics engine was one of the first things I would love to see. But yeah, Whitestorm.js gives you like simple in usage, just like 3JS. Allows you to like use Webpack, allows you to integrate with React. It's component based, and if you have like if you have a Webpack project, you can easily kind of integrate this. And there's a couple of good demos there. Right. So that's an example of kind of extended frameworks, which are great, and I hope there'll be more of them. The other tool I wanted to show you is called NinjaDev, NIN. It's also on GitHub. I'll have a link to it later on. But this allows you to, let me check the port. There we go. This is also like a tool I was missing when I first got started with WebGL. So what I could do, when you want to build something, you maybe like an intro or something. Let me see if I get audio. No, let's see, no audio here. Let me try this. Right. So we have like an intro that you want to build. In this case, this is like a 4-minute thing, and it allows me to view my project in full screen, what it would look like in the end. But also, I can jump to any point in my scene, and you can see I can see hello there, right there. This tool also provides me kind of the timeline of all the scenes that I have. So if you just want to build like a cool 15-second, 30-second intro, this is great to have. The feature that I really love of this is the almost like live reload that you would get with something like browser sync and so on. So for instance, I'm going to say, wow, live coding. I'm going to save that file. I'm going to go back to here, and I know that that's my scene right there. So you can see, wow, live coding shows up right away. And this would have saved me so many hours when I first kind of got into WebGL. In this case, I don't have to restart my tab in preview. At some point in the past, I was building something and I had to refresh my browser like dozens of times, and it would actually crash. The GPU would crash because I kept reinitializing the WebGL context. Cool. So that's NIN, and you can check it out. It's pretty great. And they've been really active pushing new releases, I think every couple of weeks. 13 days ago, version 21. It's amazing. So yeah, these were kind of the demos that a demo of like the experiences I would love to see more of, and hopefully more of the tools in the future would be that easy to use and would really simplify our work. A bit about also I want to mention WebGL 2. As I said, it came out earlier this year. It's available in Firefox right now, and WebGL 2 allows us to basically build graphics that's indistinguishable from like console or high-end PC gaming graphics. If you have the time later on, Google for After the Flood demo, which kind of provides you this, you can see like the detailed models, the clouds and the reflections, this HDR rendering and all these effects. That's all powered by WebGL 2. Yeah, and very exciting because we can start building things that you can go to a normal person and ask them, what do you think this is running in? And they probably won't say the web browser, but you can surprise them or something. Cool. So let's see. So the next thing I also want to mention VR, virtual reality. And that's been getting popular again in the last couple of years. We got new hardware, we got new stores, SDKs, and so on. And we still kind of have the same issues and kind of a bit of roadblocks with VR, where yeah, everybody's got their own store, everybody's got their own SDK, and also they have trouble like sharing the experiences they build, and also experimenting more. So this is where the web and the web platform can come in and kind of help with that. So you can share links, you can use the web engine to build things and experiment. And this is where WebVR will hopefully kind of help make VR like a thing that's you can make money with and not just kind of fool around. So WebVR basically is a JavaScript API that allows you to create this immersive 3D experience. And you can see this is a screenshot from webvr.rocks website where you can check sort of the compatibility layer. And as I mentioned in the timeline view, I'm really hoping like you can see some red X's still like next to Android and so on. They're still in the works, and hopefully in the future it's all going to be green, and it's all just going to work. And you can see Firefox 55 Unstable recently got just this month, August 8th. Mozilla shipped WebVR support in the stable browser, and also the Mac support as well. So to make it even simpler, I mean, the web platform already makes it really easy to share and kind of hack around with these experiments. Mozilla sponsors this project called A-Frame. It's open source, and we're going to have a talk on this once I'm done in like 15 minutes or so about A-Frame. And that's also a very exciting project, very easy. If you don't even like I showed you the 4 frameworks earlier. If you don't want to look at that, A-frame, if you can write HTML, you can use A-frame. And I think we did a workshop earlier 2 days ago, and in less than like 10 or 15 minutes, people started building things that they were really surprised how easy it is to get started. If you kind of want to see the most complex WebVR experiments, there's webvrexperiments.com. All you need is a cardboard to try those out, and a phone, yeah, device. And I guess one thing to mention, if you want to either get inspired or get help, there's a WebVR Slack that you can join. The Rocks channel is like the WebVR Rocks side of things, but the WebVR Slack is also very exciting. Every day there's new experiments and people share what they build. Before we get to the next part, I wanted to show a quick demo here of something where you can get away from the browser and still use the browser APIs in like you can push your experiments out to stores. For instance, this is the SteamVR store, and you can see there's in the middle there's like a game of JavaScript, and that icon sits alongside other games built in Unity and Unreal Engine. So to the end user, you don't see the difference, right? The only thing, like I'm telling you that it says JavaScript in there, so you can sort of tell that game is built with JavaScript, but the end user will not know, and they will still get the same experience as a game built with Unity or so. So this is built. I'm recorded this from my desktop view, and this is what the user would see. Same thing. They would get a loading screen just like any other game. And I know everybody's passionate about JavaScript in this room. You can have your own personal JavaScript room with the JavaScript carpet. You can look around, and it's running at 90 FPS. And you can start building a project, and you might not even release it as a website or a web app. You can package it and try to promote it this way, where publish it to a store, and just kind of that's where the end user looks for high-end experiments. Cool. That's so we talk about VR. I want to also mention AR. So with VR, we can kind of transport into these JavaScript rooms or cool experiences. With AR, we can bring some of the digital objects or digital models into the real world. So that's kind of, in the past year, that's been kind of also an interesting topic. And let me restart this. Let's see. There we go. And so there are, you can run some demos on the latest iPhones with AR, and it's still, the spec is still in the works. So it's not done yet, but doesn't mean that you can't get started building things. So you can there's a library called ARJS, which actually works with A-frame, where you can start building things. And right now it uses these markers. I have a few of them right here. And I think the true AR would be once those markers go away, but that doesn't mean you should wait for that. You can start building things and experiment and see where that goes. In this example here, this is built with 3JS. So if you can add a cube in a 3JS scene, that's all you need from the WebGL part, and then you include the ARJS library to test it out and see how that goes. So we're going to do a demo. I'm going to, Andre, you can try to go to this URL if you have an Android phone or a computer. It's ar1.vf.io. And just raise your hand, and Andre will give you a marker to try it out. And I will also need 2 volunteers to come on stage here. Raise your hand also if you want to come on stage. Okay, 1. Sure, let's go. Come in here. All right. And I'm also going to load up this demo here. All right, there we go. All right, come in here. Okay, and then we got another one. All right. All right, so you're gonna, let's see, you can hold this, and maybe, where's the other? Okay, here we go. You can hold this. Let's give you this one. Just two is fine. Take R, yeah. Okay, and you can take these two. There we go. So we're going to do, let's see. Okay, we're going to do an educational experience. So imagine you're like, I don't know, at a school and you want to teach somebody about the solar system, right? Let me see if I can go to this mic. Maybe? Yeah, there we go. All right, let's see. So come closer to me here and here. So we're going to try to see if that works. So try to hold it with, outside the square. So maybe hold, there we go, there, and then the bottom. Perfect, okay, there we go. So we got maybe a bit more space, there we go. So we got the two planets, so we got the sun and planet Earth. And we're gonna look at here, oh, okay, I need more space here. Okay, we got Saturn and Jupiter. There it is, oh, that's another sun. Okay, let's see, where's the, I think maybe this is Jupiter. There we go, so it's a bit far away, but maybe come closer a bit. Let's see. There we go. So we're going to try to fix this. We only have 4 objects, but we're going to try to fix this and rearrange this so this is in the proper order. So let's see, our volunteers, let's make it from left to right. How would things look in the solar system? You just had these 4 objects. Let's see. All right, great. All right, let's see. No, okay. So you got the sun over there. Let's see, let's try to fix this. Okay. This is a lot of pressure here. Okay. Okay, so you put, okay. Let's see, I think we got, okay, from right to left, right? That's what we're going for here? All right. So just, yeah, so move your finger from the square there. A bit, okay, there we go. So we got the sun, Earth, and, all right. Is this correct? No, okay, okay, what did you do there? Okay, you switched it while I wasn't looking, great. There we go, this is the correct, there we go. So, we're gonna have a demo of all the planets at the Firefox booth in a bit. I have all the markers, but this is kind of a quick experience, just kind of a quick demo for this AR experience. And thank you so much, volunteers. I will give you some, thank you. Thank you. One sec. I'll give you some gifts because you were so brave. Hold on. Here you go. This is for you. It's for you. And for you. There we go. They passed the exam. They deserve, I don't know, deserve some gifts. There we go. Great. Great work. I'm happy with that result. Right, let's see if I have anything else to say about AR really quick. Right, so yeah, as you saw there, you can start building things. You can make it more complex, build, make like meteors and stuff like that. And this tech is only going to get better. And ask me if you have any questions about it later on. Cool. And one last thing, I guess, we were going to talk about WebAssembly. And for those who don't know, I think we had a talk about this yesterday. But just to remind you, WebAssembly is like a low-level bytecode format for browser client-side scripting. Currently, it supports C, C++, and Rust. And it allows us sort of offload some of the intensive tasks, CPU tasks that JavaScript has to deal with, offload those into this low-level format. So there are a lot of good kind of intro articles about WebAssembly, about how great it is and so on, but I was trying to find an example of how realistically this would work out if you would want to like integrate WebAssembly into like your own either production application or your own app. And let me get this demo running. So I got it on port 8080. And this is going to be the visualization of the after party today at 11 p.m. So, and I guess there's going to be some music there. I imagine it's going to be dubstep. So we're going to, let's see. So we're going to do, we'll take it. So that's going to be, that's the demo of the party today. And I imagine there's going to be more people. So we can do, more people are going to show up. So let's do 30 people. And we can start seeing in our FPS counter there in the top left corner, it's not looking good. It's basically running the graphics in, oh yeah, sorry, a royalty-free dubstep. I must show the credits. That's the credits for the dubstep. It's royalty-free. All right, I did it. Okay, so back to this. We have our low FPS demo, and this is not cool. This is not good dancing. It's running 8 FPS, and you're asking me, like, why are you showing me this? This is not, I thought WebAssembly is supposed to make things fast. So before I get to the WebAssembly part, I guess to describe what is happening in this demo, every character is animated, and it's used as a concept called skeletal animation, and which means I have certain, like I have this 3D model, and it has certain points which I can move around in space, and then the whole body reacts to that movement of that point. So the the shoulder kind of moves related to that point that I'm moving, and every character is animated in its own way. This one is doing some crazy stuff just now. So, right. So we can let's go back to the. Let's see if I can. We're gonna turn on some dubstep here, and what we're gonna do is we're gonna wait for the dubstep drop and turn on WebAssembly, and you can see. So you can see I'm actually back to 60 FPS once I turned WebAssembly on. And you can see I'm at like 30 characters. I can go like to 60 characters, and I have a really smooth experience. I'm at 43 FPS there in the top left corner. So a bit about this demo, I guess. I wouldn't dare to switch back to JavaScript here because it might freeze my presentation. So just got to be careful there. But this is kind of an example where initially you would have an app that was something like this, and you built your JavaScript app, you ship it, and then somebody it's like I want to have 100 dancers, and like it reports 1 FPS. So you got to fix it. So what do you have, right? So here's an example here. So you imagine you wrote some algorithm for this animation, and here it's on the left using TypeScript. Everybody knows the TypeScript syntax because there was just a presentation on that. And we can take a look here. Let's see. We have our skeleton animation function, and I can comment it out and just say, change some code, ratio 20. Oh, it's actually, okay, ratio 1. And if I would save that, you'd probably have like Webpack running in the background. Let's see. I'm going to do npm run. I can't remember what the command was. Let's see. Probably npm run Webpack. There we go. And it would compile some files and will include this algorithm that I made a change to. If I go back here, refresh this demo, let's see if it applied the change. Let's see. So I think you can see they're started shaking a bit more. That's because I changed the algorithm, and they're kind of moving around more left to right. So this is kind of the regular, this is what you have in your app right now. And you notice the FPS drops. So what you basically can do is you can say, okay, I'm going to rewrite this algorithm with C or C++. And you can see here it's on the right. This is the C file here. And it has the same function names. So you have get transform at time in C++. And I can, same thing, I can do float ratio 1, comment this out, save it. And in this case, I would be, I would have to build it as well, like very similar to Webpack, where you can, we can take a look here at the package JSON. The same way we run Webpack here, we can run the mscripton SDK and compile this file from our C++ file into this WASM module. And that WASM module can now replace a bit of your code in your JavaScript code base with this WASM file. And yeah, from there on, you can same way you would refresh the browser or live reload it, and you would get your WebAssembly module loaded, and you get the smooth experience there. And thanks for Cameron Peterson for putting that demo. I think it's one of the most powerful demos there is. I have this slide about how to get the SDK. You can take a look at it later. And if you want to read more about WASM WebAssembly, there's a Mozilla blog and also the .org website. If you want to start building these modules that are kind of optimized as pieces of JavaScript into these low-level languages, WASM Init is a great project to get started. Lastly, actually, let's see. Oh, one thing I want to mention, which is our recent news. So I showed you this experience where I have Webpack and the Mscripton SDK. Good news is Mozilla is sponsoring. It's giving $125,000 to Webpack to make WebAssembly like a first-class citizen, first-class support in Webpack. So you make it really easy for you to substitute this slow JavaScript code, slow JavaScript algorithms with these low-level pieces. And lastly, also, if you use tools like Unity or Unreal Engine, you can also use WebAssembly in there, where you can target. You can just basically check a checkbox, and Unity will export a WASM module if you're building like a game or experience, and use WebAssembly that way. So those tools already have experimental support for WebAssembly. Great. That's it for me. I'm right almost on time. If you need the slides, they're available at vf.io/3dweb. You can see this reference list in those slides as well. And thank you so much, Brazil. It was great. Obrigado.
Agora, vamos sair da Rússia diretamente para a Espanha, porque o nosso próximo palestrante, né, ele vem de Madrid. Ele trabalha na Mozilla como Developer Advocate e ele vai falar, cara, ele é um dos caras que desenvolveu aquela plataforma de realidade virtual online da Mozilla. E é sobre isso que ele vai falar. Eu quero pedir uma salva de palmas para Salva de la Puente! Tem que ser nesse tom, né? Mais, gente! Porra! O cara veio de Madrid pra falar com vocês querem um aplausinho, porra! Agora,